Hello and welcome to the lecture on summarizing and displaying frequencies of quantitative data. So basically what we're doing here is we have a tremendous amount of quantitative data. And when we have quantitative data, we need a really quick and easy way to be able to display that data for other people to be able to understand what's there. So in order to do that, you might have 180 pieces of data and you've got to split that up and categorize it so it's really easy for your consumers to be able to see the data that you're trying to present. So this is a four-step process. The very first step is first you need to decide on the number of classes. You have 180 observations. You need to figure out, okay, how can I break these 180 observations up into really easy to understand classes? Next, after that, you determine the number of, or the class interval. In other words, you might have, 15 classes, and so each class might have an interval of 10 units or something to that effect. Next, after that, you set the individual class limits. The class limits is the high and the low point of each class. And then after that, you tally the data into classes and determine the number of observations in each class. Okay, so let's keep moving. So this is a frequency, we're working on constructing a frequency distribution. So right here we have a total of 180 observations, and with these 180 observations, we first need to determine the number of classes that we need. And in order to do that, we need to use the 2 to the k is greater than n rule. In this case, n is 180. So let's see here. Let's write this. Pen. Okay, so 2 to the k is greater than n. So n is 180. Oops, I don't like that. Well, 180, sorry. I don't really like that, but n is 180, and so 2 to the k, let's see if I can fix this. 2 raised to the whatever is greater than 180. So 2 raised to the, like for instance, 2 raised to the 6th. What is that? 2 raised to the 6th should be 64. 2 raised to the 7th is 128. 2 raised to the 8th is 256. So 2 raised to the 8th is the first power that is greater than 180. 2 raised to the 8th is the first power that is greater than 180. Let's see here. It doesn't matter. 2 to the 8th is the first power that's greater than 180. So the number of classes that we need to split it up to is right around or at least 8. So right here we're going to use 8 classes. Next, after we've determined that we're going to have 8 classes, we need to determine how wide the interval is going to be. So in order to do that, you need to look at the highest value and subtract the lowest value and divide it by the number of classes. So if you look at the previous slide, you have the highest value right here. You have the lowest value right here. So you take the highest minus the lowest and divide it by the number of classes. So the highest minus the lowest, which gives us the range, divided by the number of classes, gives us an interval of 374.75. However, 374.75 is kind of an ugly number. It'd be really weird to have classes that had the width of 374.75. When we're displaying data, we want it to look really pretty. So instead of having 374.75, we should round it to something really pretty, and preferably round it up if you want to keep 8 classes. But if you're okay with having, like one more class and it's close, it's okay to round it down and add an additional class or 2 if it makes sense with the data. So here, instead of 374.75, so I took the highest value minus the lowest value and divided by the number of classes. So instead of 374.75 for that, I'm going to round it up to 400 for the interval. Okay, and also oftentimes the interval is referred to as a class width, and in Megastat, for instance, it refers to it as width. So the next step is to determine the lower limits and the higher limits, or the lower and upper limits. So the lower limit should always be below the lowest value. So the lowest value here is 294, which you see right here, 294. So it needs to be below 294. So in this particular case, it's really clean to go down to 200. So the first class is from 200 all the way up to 600, because remember the interval is 400, right? So you've got an interval of 400 for each one of these classes. So this is class 1, class 2, class 3, class 4, class 5, class 6, class 7, class 8. And every single last one of these has an interval. And when you have this, it's 200 up to 600. That means 200 up to 599.99 inclusive. 600 up to 999.99 inclusive. And so these are the lower and the upper limits for the classes. Next, what they did here is they went into the original data and by hand they found every single value that was between 200 and 600. So let's see how annoying that is for a second. They come through here and they're like, oh, here's a value that's between 200 and 600. They keep going down more, then they go up. Where's the next value? Ooh, we've got some more values. We've got another one, another one, another one. And, you know, they just cross them off as they get through them all. And so this entire chart is made by hand as they find values that fall into these buckets, if you will. They tally them for the frequency. And so the frequency right here is the number of observations that occur between 200 and 599.99 inclusive, between 600 and 999.99 inclusive. So 11 for that. Next, the relative frequency distribution. Okay, so the relative frequency distribution is you've got 8 right here divided by 180. 8 divided by 180, which you also see right here, gives us how many times 8 occurs, relatively to the entirety of the pie. So 8 divided by 180 gives us a relative frequency of this occurs 4.4%, or the relative frequency is 0.044. So make sure if you put it as percent, this is a 4.4% occurs, or 600 to 1000 is 6.1% is the relative frequency. And so the relative frequency is right here, and you can use relative frequency to see how one individual class compares to the whole. So right here you can see this 0.25, how one individual class compares to the whole. Okay. Next, we have something called a histogram. A histogram is a graph, and really important, histograms, which this isn't actually in the definition. Histograms are for quantitative, where bar charts are more for qualitative. Histograms are for quantitative, where bar charts are for qualitative. So right here, you've got the histogram, and the big difference is that histograms display continuous data with no meaningful gaps. So you notice that right here, there is no gap between these two classes. And the reason why is it goes 200 all the way up to 599.99 and 600 all the way up to 999.99. So there's no gaps between it at all. So that's a histogram. And then on this axis right here, you're going to see the classes, and on this axis right here, you're going to see the frequency. In other words, how many times the class occurs, or how many observations of that class there are in the data set. Now what's really important is in Megastat, by default, they don't have frequency on the left-hand side. They have percent. So just be aware of that you might want to change it to frequency instead of percent. But it is really good to have frequency in order to be able to compare the frequencies of the classes, of the occurrences of the classes in the data set. So those are the two big differences, is that there's no touching right here, and well, that's the one main difference. And then on the bottom, you're going to have quantitative data instead of qualitative data. So this right here, a frequency polygon. A frequency polygon is essentially the exact same thing as a frequency, or as a histogram. However, like for this particular instance, what a frequency polygon does is notice that this right here, this is the midpoint. This is also the midpoint right here, and this is the midpoint. So these are the midpoints of each class. You see the midpoints right here. So you've got the midpoints of each class there instead. And so you're able to have this, and it's pretty much identical to this histogram. So look at the histogram, look at the frequency polygon, and they're pretty much identical because they say the exact same thing. But what a polygon will do is it will allow you to put two sets of data on top of each other. So say, for instance, you've got this month's data, but you want to compare it to last month's data. So you might have data that looks like, this, and you'd be able to compare the two charts. Which I know that looks absolutely horrible, I'm sorry, but I'm doing that with a mouse. But you'd be able to have multiple sets of data that are all over the top of each other and compare them simultaneously. Where with a histogram, you wouldn't be able to lay a histogram on top of a histogram because you would be losing some of the data. Okay, next. This is called a cumulative frequency distribution. With a cumulative frequency distribution, this is really beneficial if you want to see, like for instance, the number of observations below a particular point. And notice I say less than 2,200. I don't say less than or equal to 2020. So if I were to ask you, for instance, what are the number of observations less than or equal to 2020? Or sorry, less than 2020. Or 2,200, sorry. What are the total number of observations less than 2,200? And that's going to be 125. The way that we got that is we added the frequency of class 1 to the frequency of class 2 to the frequency of class 3 to the frequency of class 4 to the frequency of class 5. Okay? When you add up all of these together, you get 125. If you only add up these 4, you get 80. If you add up these 3, you get 42. If you add up these 2, 19. If you just do this one, it's 8. So if I say how many are less than 600, it's going to be 8. How many are less than 2,600? It's going to be 157. How many are less than 3,400? It's going to be 180, which would be all of them. Also, you could put the percentages here, which Megastat does that for you. Megastat puts another column right here that has all the percentages. And so you can say what percent falls below 1,800, what percent falls below 3,000, what percent falls below 1,400, and it gives you that percent. Next, we have a cumulative frequency polygon. Okay, notice the cumulative frequency polygon comes down here and goes all the way up to the top. And the reason why is because, it starts at 0 and goes all the way up to 100%, or starts at 0 and goes all the way up to the total number in the frequency, which is 180. So if I were to ask you, for instance, looking at this graph, how many occurrences or how many data points or how many cars had a profit, how many car sales had less than $1,600 profit, you'd be able to look and see, okay, 60 cars have less than $1,600 profit. Or, what percentage of cars have greater than 2,000 profit or less than 2,000 profit, and that would be 55. 55% of cars have less than 2,000 profit. So that is a cumulative frequency polygon.